So we should know from the first video that inverse functions at corresponding points have reciprocal slopes. So that just means, as we see above here, if you have a slope as 11, then the reciprocal slope or the inverse slope would be 1 over 11. So it's not the opposite, it's just the reciprocal. Okay, example 4. Given the function g of x equals 2x cubed, find the inverse prime of 3. So we have to find the slope of the inverse. So if we know the slope of the original, we would just do the reciprocal. So first things first, identify the corresponding points. So g inverse, the corresponding point would be 3 and then question mark. And then for g, that means that the 3 becomes the y value because x and y switch. So in order to find this missing value here, well, we have some information that we can use. We know that this is the y value of g, so what we can actually do is set that equal to the original function. Now here, all we have to think about is what value would x have to be in order for the left side to be 3. So in this case, x would equal 1. Now what this allows us to do is we can take the original function and find the derivative. So we get 6x squared plus 4. Then if we find g prime of 1, we get 10. So now we have the slope of the original function of g at the value for 1. So we can find the slope for the inverse by doing the reciprocal. So this should actually say g inverse of, actually 3 is what we're looking for because that's what they asked us for here. That then becomes the reciprocal as 1 over 10. So this little box that we have here, the most important piece that we have to think about or worry about is this bit right here. What this means, if you remember back to composite functions, if we have two inverses and we do the f of g composition and g of f composition, what should happen is you should remain with the value that you put in, because these two functions are inverses, which means they do and undo. And how that looks in terms of slopes is the derivative at b is 1 over the derivative of a. It just means your x and y switch is all this means. But if you have the slope at one value and we have the corresponding point, then that means it's the reciprocal for the inverse slope. Let's do example 5. F of 0, do that first. We should get 2. So that tells me the coordinates or the corresponding points that we'll find in a second is going to be 0 and 2. Over here it asks to do f inverse or prime of 2. So we have to find the slope of the inverse. Okay, so that tells me then that f inverse corresponding points are, this is 2. And then if this is 2, according to the fact that these are inverses, this is 0, 2, this would be 0, would be 2, 0. So in that case, if I know the slope of the original function by finding the derivative, that gives me 2x to the 4th plus x squared plus 3. And if I find f prime of 0, because that's the corresponding point I'm using, I should get 3. That gives me the slope at the point 0 is 3. Therefore the corresponding point, f inverse prime of the corresponding point, which is going to be 2, gives me 1 over 3 for the slope. Example 6. So it says if m of n of x equals x, blah blah blah, what this means is m and n are inverse functions. So what information do we have? We have m of 5 equals negative 9. That means the corresponding point is 5, negative 9. If we look at n, then that means that it should be negative 9, 5. We're given m prime of 5 is negative 8 over 11. That's the slope. So we want to find n prime of negative 9. Well, that makes sense because we've switched, we've got the corresponding points, which means it's going to be negative 11 over 8. So we're given no equation there, and we're still able to find the slope given certain pieces of information. Alright, example 7. Selected values of one-to-one differentiable functions, f and g, and actually f prime as well are given in the table below. If, what that tells me is, f and g are inverse functions, we have to find g prime of -3. Okay, so notice that g prime is not actually in the table, so we're going to have to use the f prime somehow. So let's go back, find our information. So f and g, find the values. I do know that -3 is an input for g, which means it would have been an output for f. So there are a couple of ways you can do this. If I look at the input for g, that's x being -3, then the 7 is the output. Now if I did not have that information, I could look at here and realize that -3 is actually the y. And if I go over, excuse me, over to f, and being the y one of these values, that tells me that this is the y value, this was the x value, therefore I can get it that way, excuse me, as well. Okay, so I need to find g prime of -3, which if I know f prime of 7, then I can get g prime. And again, g prime is not in the table, but f prime of 7 is. F prime of 7 is 2, which means g prime of -3 is +1/2. Right, next, the derivatives of trig functions. So this table here has got a lot of information, all these derivatives of the 6 trig functions. What we need to do is memorize these. But first off, let's derive and show where the first one comes from. Alright, so we have y equals arc sine of x. Find the derivative. So currently we do not know how to differentiate this. We have this table down here as a clue, but that's a lot of information to make that leap. So what we do know is if we take the sine of both sides, the sine of the arc, sine of x, well, please remember that sine of the inverse sine of a value, these would effectively, they're opposite or inverse operations, therefore they cancel, meaning that sine of y equals x. Now we can go ahead and differentiate both sides. Since there's a y here, we have to do it implicitly. So the derivative of sine is cosine y. This is the derivative in terms of x, so it would be cosine y times dy dx, so the chain rule. And then the right side is going to just be 1. So dy by dx equals 1 over cosine of y. That doesn't really get us to the answer, so we're going to take a step back and look back here. We have sine of y equals x. Now, what this means is we're doing... So to make it easier for your brain, think about it like sine theta. So think... Hopefully everybody knows that sine theta is y over r. Now where we get confused with this is because we have this y and this x in a weird place. So over here I'm going to draw a triangle. Okay, so we know that theta would normally be here. According to this problem, that's actually y, that's your angle. If it's x over, or if it's y over r, that means in the y position I'm going to write x, which is hard to think about, but that's what we have to do in order to figure this stuff out. Okay, so using Pythagorean theorem, we have a squared plus x squared equals 1 squared. Therefore, a equals the square root of 1 minus x squared. Now, hopefully you're seeing 1 minus x squared down here, so we're getting there. Alright, so this side length is 1 minus x squared, so the square root of the quantity 1 minus x squared. So go back to our problem, and we have dy by dx equals 1 over. We need to do cosine. So cosine theta, remember thinking about this, my little brain bubble, whatever, is going to be x over r. So it's where your x position is over your r. In this case, our x is the square root of 1 minus x squared. In fact, let me write it out here. According to this problem, remember it's going to be cosine of y is going to be square root of 1 minus x squared over r, which is 1. And then final answer, dy by dx. We can, remember this is right here is our original fraction bar, multiply by the mess there, so we've got 1 over the square root of 1 minus x squared. And that is a derivative of arc sine of x. So notice we have arc sine, arctan, arcsecant, cosine, cotangent, cosecant. So the cos, if you like, over here. The only difference between this one and this one is these are all positive in numerator, these are all negative in numerator. So ideally, if you could memorize these ones, then in matching these ones up correctly, you just put a negative, multiply a negative 1, etc. Okay, let's now apply this. So, looking at this problem, wants us to differentiate 4x plus arcsine of 2x squared. So this would be easy enough to do if it was just arcsine of x, this problem right here. So there's a couple of different ways to do this, but it does involve the chain rule in some capacity. So one way to think about it is if we rewrite, this is not part of the actual problem, if we write as arcsine of u, which means that u would be 2x squared. In order for us to do the chain rule, u prime, 4x, according to the problem, we need 1 over the square root of 1 minus the something squared. So if we think about this as u, and u, I'll show you how to make it a little bit easier in just a second. Then we also need u squared. Remember, the reason why we're doing u prime is because we need to do the chain rule, and you'll see this showing up in a second. U squared is going to be 2x squared, all squared, which is 4x to the 4th. That gives me u squared. Okay, why do I care? Alright, well, I'm actually going to use arcsine. I'll come back to the 4x in a second. If I do arcsine of u, and I find the derivative, notice that it's x and u and all this mess, it's going to be 1 over the square root of 1 minus u squared. I also need to multiply this by u prime. So it's actually a little bit easier, especially when you start having everything other than x in here, to think about it as u prime over square root of 1 minus u squared. Remember, where u is the thing that we're taking the sign of. So arcsine of something equals something differentiated over 1 minus square root of 1 minus the something squared. Okay, so let's put all this together. I've got a bit of a mess going on here. Derivative of 4x becomes 4 plus, it's going to be 1 over the square root of 1 minus, well, u squared is right here, so that's 4x to the 4th power. And then I multiply that by the derivative of the inside, so 4x. So final answer, 4 plus 4x over square root of 1 minus 4x to the 4th. Whether you use u, whether you just use the chain rule, it's the exact same thing. It might be easier for some of us to think about this problem as u prime over 1 square root of 1 minus u squared, or just do the chain rule. Either way is perfectly fine. Okay, this next problem. So we have a product rule here. So we have, actually, let's move this down here. We have x, and we have arctan of x to the 1/2. It's easy enough as 1. Here, well, the arctangent of x is 1 over 1 plus x squared. So that gives me 1 over, we're doing the outside, 1 plus, so x squared, actually, is x to the 1/2 squared, so I'm doing it technically without the u piece. This gives me 1 over 1 plus x times the derivative of x squared, which is 1/2 x to the negative 1/2. Need to do a little bit of tidying up here. So I have 1 over, the 2 comes to the denominator, this x to the negative 1/2 becomes x to the 1/2 when it comes to the bottom, or the square root of x, times 1 plus x. Oof. Okay, so let's apply the product rule, and we have arctan square root of x plus, that's these two multiplied together, and then x times this. So we'll have x over 2 times the square root of x times the quantity 1 plus x. and then we're finished. So there, I didn't use u, I just applied the chain rule. Either's fine. This next one, I am actually going to use u because there's a lot going on here. So first of all, I'm going to rewrite this as 1/5 arc secant, and I'm going to write it as u. I'm going to let u equal sine of 3x. That means u prime is going to be 3 cosine 3x, and u squared, why do I need that? Well, secant, over here and look at it, is 1 over the absolute value of x times the quantity x squared minus 1 square rooted. Ugh. So it'll be 1 over the absolute value of x times the square root of x squared minus 1. Okay, so I need u squared or x squared. That becomes sine squared of 3x. So we've got all the pieces there, we just need to put it together. There's not a product rule here, there's not a quotient rule. We're just about to differentiate this. So this becomes the 1/5 on the outside. If I follow u prime over absolute value of u times u squared minus 1, it's kind of easier to put everything together. U prime becomes 3 cosine 3x over u, so that's going to be absolute value of sine of 3x, times the square root of sine squared 3x minus 1. And depending on if it's a multiple choice answer or if it's a free response, if it's free response we can stop there, if it's a multiple choice we might need to go a little bit further. Alright, example 9, differentiate then simplified a single term. So notice that we're going to have different parts here that we differentiate, so let's get started. Y prime is 1 over the square root of 1 minus x squared. This is a product rule, so I have x and I've got 1 minus x squared to the 1/2. This gives me 1, this gives me 1/2 times 1 minus x squared, so chain rule, to the negative 1/2 times the derivative of the inside, so negative 2x, watch that, I'll drop that negative. This can be tidied up to be negative x over, so the 2's will divide out, square root of 1 minus x squared. That's square root. So that gives me, remember we multiply and add, so we're going to have plus 1 minus x, actually, let's write it as a square root of 1 minus x squared, plus minus x squared over the square root of 1 minus x squared. Oof, bit of a mess here. I want to have the same denominator. If I put this over 1, then what I'm actually doing is I can multiply top and bottom by the square root of 1 minus x squared. And what will happen is I'll have y prime equals 1 over square root of 1 minus x squared. Once it as a single term, so I'm going to have to put this all together. This times itself is going to be 1 minus x squared, just like the square root of 2 times the square root of 2 is just 2, over the square root of 1 minus x squared, and now I have square root in both of these, and then the last one was always there. And we just have to tidy it up. So final answer, y prime, I'm going to have 2 minus 2x squared over the square root of 1 minus x squared. So it asked specifically for a single term. Done. Okay, example 10. We're only going to find the first part, we're not going to find the equation of the horizontal asymptotes. So find the coordinate, that coordinate means that we're looking for an x and a y value. Horizontal asymptotes mean that we have to set it equal to 0. Be really specific, make sure that you write this on the AP exam. They'll be expecting that, you'll lose points if it's not written there. So g prime, this is going to be a chain rule. So we have the derivative of the outside, 2 arc tangent x, times the derivative of the inside. The derivative of the inside is 1 over, luckily there's no weirdness, it's just tan x, arc tangent x, so 1 plus x squared. I can put that together. 2 arc tangent x over 1 plus x squared. We know that we have to set this equal to 0, but it's actually just the numerator. Okay, divide both sides by 2. So we have 0 equals arctan of x. Now, we are not used to seeing arctan a whole lot, so I'm going to write it like this. This actually means it's the same thing as tan of theta equals 0. When I take the arc tangent of something, I get an angle. So tan of theta equals 0. So that means tan theta, if you think about the unit circle, or the graph, think about where it's going to be just 0. That has to be, remember, it's y over x, which means 0 has to be for the y. So that's 1, 0. Where else is it going to be? Right here, which is negative 1, 0. Now we could keep going and finding multiple points. It doesn't actually restrict it. Let's just assume we find the first two. It will be more specific. 0, maybe also pi. We now have the x values. All we need to do now is find the y's. And we have to put that back into the original function right here. So that would be, and it's a little bit too difficult for us to do without a calculator, so it's going to be the value 0 and arctan of 0 squared, and then pi and arctan of pi squared. Okay, last problem. So rewrite tan arc cosine x squared as an algebraic expression. Alright, so anytime you take the tan of something, you're always taking the tan of an angle. Inverse tan, you take the tan of a ratio. Inverse tan of a ratio. So what really is going on here is this. We want to find tan of theta. Okay, so let's look at theta equals the arc cos of x squared. Actually means theta equals inverse cos of x squared, which means cosine theta equals x squared. So think about, remember, cosine theta, I want you to think about it, is x over r. We get confused because these x's are showing up a bunch. So we're thinking about it like this. Okay, so let's draw this out. We can feel free to put theta there. This tells me that this is x squared, and this becomes, this is 1, because it's over 1. So doing Pythagorean theorem, it's the square root of 1 minus x to the 4th. So that means thinking about tan theta as y over x. Remember, this is us thinking about it. It's just weird because of all these x and y's all over the place. So for the purpose of the problem, tan theta equals, well, y is this craziness here, square root of 1 minus x to the 4th, and x is x squared. So this would be your final answer. Okay. I want you to take a minute and try this problem, and we'll go over the answer next class.